Again, you're welcome to another class. We have another exponential challenge here. The question is 3 to the power of 2t equals to 7. Let's see how we solve and verify this. Okay, at the end, we're going to verify the answer we got to this challenge here to see if it actually satisfies the original equation. So stay till the end and see how this can be verified. So we're looking for our t equal to what? So we're taking our solution. All right. So again, the question is our 3 to the power of 2t equals to 7 here. Now, there is no much protocol here. Just go straight to taking log to either base 3 or to base 10 of both sides of the equation, or ln both sides of the equation. Either way, we give you the same answer. So you want to take log to base 10. Okay? So if we log both sides of the equation, we're going to have here log 3 to the power of 2t, okay, base 10 equal to our log 7 base 10. Easy. Applying the property of logarithm, which says that when you have a power here, then take it backward. It says that if you have your log, let's take our a to the power of p, the base 10, then this is equals to our p times log ra, the base 10. Okay, this is what we call the power law of logarithm. So if we consider this, we're going to move this 2t back here times our log 3 base 10 equals to our log 7 base 10. Easy. Now, we're looking for t, so we quickly divide by log 3t. Okay, sorry, log 3 base 10. So we have here dividing by log 3 base 10, dividing by log 3 base 10. This will leave, right? Good. So we are now left with our 2t on the right hand side equal to, here we have here log 7 base 10 all over log 3 base 10. Easy. So we are still having 2 attached to our t, so we divide through by 2 again. So we have 2t all over 2 equal to our log 7 base 10, right? Good. Then all over our log 3 base 10 dividing our 2. Okay. So we're going to change this to multiplication sign. And when we change it to multiplication sign, mind you, we have this all over disable 1. So the 1 goes up and the 2 comes down. And so this will leave. So we now have our t will now be equal to our log 7 base 10 all over our log 3 base 10, then times our 1 all over 2. So rewriting this will now give us here our 1 all over 2 times our log 7 base 10 all over log 3 base 10. Okay, so yeah, this is the answer, but we want to change this to another base. We're having base 10 here, but we want to change this to base 3. So we apply the change of base law, which says that when you have your log, if you have log a, right, base b, change it to base k, will give us log a base k all over log b base k. Okay, so what happened? We can now rewrite this as our 1 all over 2 times our log 7 base 3. So these are the two forms of presenting the answer. So either this or this. So we want to do a simple check to see if this answer actually satisfies this original equation. So from our check here, we're going to have your check. The question is 3 to the power of 2t equal to our 7. So wherever we see t, we put in this value in there. So this is going to give us our 3 to the power of 2 into 1 all over 2. So we have 1 all over 2 times our log 7 base 3. Let me write it where, please. So I have 7 here, base 3, close bracket, equals to 7. Okay. So what we do, look at this here. This 2 is multiply everything here. And so this can go with this. So we are now left with 3 to the power of our log 7 base 3 equals to 7. Now we apply another law of logarithm, which says that if you have your a all raised to the power of log, let's take b, base a. Look at your a as the base here, and we're having the base of the log to be a. So this, we go with this. So we are now left with what? B. And so look at here, we're having 3 here, and we're having the base to be 3 here. So this, we go with this. So I'm now left with 7 equals to 7. So 7 equals to 7 proves that the answer which we got here, t equals to 1 over 2 times our log 7 base 3, satisfy the original equation. Okay? All right. It's a simple one. This brings us to the end of this class. See you in our next class. Thank you for being there. Bye for now.